one important thing is to have multiple people involved in the development of these models, people from different cultures, different backgrounds.
Welcome to another episode of the AI Purity Podcast, the show where we explore the complex intersection of artificial intelligence, ethics, and its societal impact. I'm your host, Patricia, and today's guest is an assistant professor of computer science at the University of British Columbia and a CFAR AI chair at the Vector Institute. Our guest's research endeavors encompass computational semantics, pragmatic reasoning, and building AI models capable of human-level understanding of language. Her impactful contributions as a postdoctoral researcher at the Allen Institute for AI have been marked by a relentless pursuit of uncovering implicit meaning in human speech and developing culturally aware NLP models. Join us today as we delve into the future of NLP, the ethical implications of AI technologies, and how we could shape a more inclusive and responsible AI landscape with Dr. Vired Schwartz. Hi, Dr. Vired. How are you doing today?
Good, thank you. How are you?
I'm great. Thank you so much for being here. Well, please tell us, share with us what initially drew you to the field of computer science, more specifically, the intricate domain of natural language processing.
So I think that what drew me to computer science is that I love problem solving. I find myself doing it in my personal life as well, always trying to um, solve a problem. I do like the problem solving aspect of computer science. And in terms of language, I sort of randomly got interested in the field by taking an NLP course in my undergrad in the last year of my undergrad, and I was really interested in that, and decided to pursue a master's and then a PhD. And things got more and more interesting over time, because when I started, it was just when like around the time that deep learning was starting to take over NLP, and so it was a very interesting time. And also over the years, I have been working on natural language processing in English. And as a non-native English speaker, I was always really interested in the semantics aspect and the meaning of words and sentences, as I was also learning and improving my English. And I saw the parallel between me improving my English and teaching the software to speak, to interact in English with users. So a lot of my work today is also about how we understand language and sometimes misunderstand language as well.
And as an AI researcher, what motivated you to delve into the realm of implicit meaning and advanced reasoning skills in machines?
I think I've always been more interested in the more like real life or like social aspects of computer science. I think that's how I ended up working on NLP. So I found that while I was working on during my PhD, I was working on lexical semantics, which is about the meaning of individual words and how the meaning interacts when they combine with each other into phrases. So I've worked on, for example, noun compounds like olive oil versus baby oil, which like have the same head noun oil, but have very different meaning. And the meaning in that example is actually implicit. So we use this kind of like condensed form to convey the meanings of oil extracted from olives or oil used for babies. And we know very well, even if you're I don't know, and you've never encountered this term before about baby oil, you would probably know very well that it's not the same as olive oil. It's on oil made of babies. And so I was really fascinated with how kind of easily or seamlessly we understand language, even when it's using these kind of shortcuts or is underspecified or is highly ambiguous. And at least at the time when I started, computers were very bad at this. They are getting better, but they're still, when you use these kind of examples that are very clear to people, and that would basically rely on people's common sense to interpret, you can sometimes find a failure example that even really strong models, language models like ChatGPT or GPT-4 fail on.
And how do you perceive the current state of natural language understanding in AI, particularly in the terms of capturing, like you said, those nuanced meanings and context?
I think we've made a lot of progress. I personally, as someone who has been working in the field for many years, I've been really impressed by the achievements of models, large language models, like starting pretty much from ChatGPT, but then all the follow-up models as well. So these models basically, the technology at the basis of these models, like predicting the next token, has been around for a long time. But the main thing that changed was they became bigger with more parameters and trained on more data. And there are some like additional training objectives that do make a difference, but mostly it's these models size and sheer amount of training data that makes them so powerful. And I was actually impressed because I didn't think that scale can get us this far. I don't think they do reasoning the way that humans do. They're not as robust. You can see some of their main limitations, one being the hallucination problem, because now, so language models, because they have pretty much read all the text in the web, then we also rely on them for applications that need factual knowledge about the world. And they're not really reliable. They do have a lot of knowledge about like virtually any topic that was discussed online ever, but they make some mistakes. They don't really have a notion of the truth, and sometimes they just make up facts, and it's not easy to detect that for a user. If we don't know the topic very well, it's not going to be easy to detect. And so that's a huge problem. In addition, they're not doing reasoning like humans do. And they're not very robust in terms of if you change the phrasing of the question, you might get different answers, which is something that you would not expect from like a person that you're talking to. But again, they're very good. So I kind of went from, very easily finding examples where NLP models fail to having to really like test the models very carefully until I find an example. But to me, just showing an example that would be really obvious to people where language models fail on them shows me that they're not actually robust and they're not reasoning the way that humans do.
And what would you say are some of the key challenges that you face in your research on developing machines so that they may have these advanced reasoning skills that you said they lack?
Okay, there's been a lot of work on large language models that claims that they are reasoning. I haven't seen enough evidence to convince me that they're actually reasoning. So, for example, there are some benchmarks that require multiple hops of reasoning. So, for example, I don't know, there's something in the question that is implicit, and in order to get to the answer, you need to make a few steps of reasoning. And there is a long line of work right now called chain of thought that asks the language models to basically think out loud and generate their reasoning steps that lead to the answer. And while I do like this line of work, I've done something very similar, but also very primitive a few years ago. I don't think it's actually doing reasoning, like proper logical reasoning. I think it's basically, I don't see that we can expect that from language models, because what they are trained to do and what we do with them when we use them during inference is we basically show them the text and then we ask them to predict word by word the most likely next word. And this is not how humans do reasoning. And so what they do is they just generate text that looks a lot like reasoning and is very convincing for us when we read it. And it's often correct because it has seen a lot of examples for reasoning in its training data, but it's not necessarily, human-like reasoning. And sometimes you can actually get the correct answer with a flawed reasoning chain or vice versa, because it's not actually relying on, or like, it's not guaranteed that the reasoning chain actually leads to the answer or faithfully describes the reasoning process that the model had gone through.
Could you elaborate on the concept of culturally aware NLP models and their significance in bridging linguistic and cultural divides?
Yeah, so as I mentioned, even though my native language is not English, I have been working on English NLP throughout my entire career so far. And the reason for that is because most of NLP most of the advancements in NLP they usually start with English, and then once we have a good model for a good English model, we try to apply it to other models, other languages, sorry. And there is a lot of work on NLP for other languages, but one of the main problems is that this paradigm that we rely on, which actually didn't only start with large language models, it's deep learning in general, which has been dominating NLP for over a decade now. It actually requires a lot of data to get high quality models. And so you could get high quality models for English, you could get high quality models for Spanish or German, any language that has a lot of web data, web text. But there are low resource languages that don't have a lot of representation online. And the models for these languages are much worse. They're of worse quality. And in addition, some languages are more morphologically rich than English. So that means that they use a lot of like suffixes and prefixes. And so there's like a root word, but then there are many different words in the vocabulary because of all the suffixes and prefixes, which complicates things a little bit further. And if you take a model that was developed with English in mind, and then you try to apply it to a language that has like a different morphology or different, I don't know, word order or different like properties, then sometimes it doesn't really work that well. And so it's not that there aren't models in other languages, it's just that they're not of the same quality. And recently it has become more popular to have these large language models trained on multiple languages, so they're multilingual. But I personally, I had to look at some data from GPT-4 that it generated in Hebrew, which is my native language, and I was really surprised by how bad it was. It's not even such a low resource language because there is Hebrew text online. It's not, there are languages like African languages or indigenous languages that have almost no text online. Hebrew does have some representation, but it was still really bad. It was making up words that don't even exist. They look like Hebrew words, kind of like learn the statistical properties of like how suffixes and prefixes combine. But it was ungrammatical. There were a lot of made up words. So even these multilingual models don't completely solve the problem. And so there are a lot of researchers working on multilingual NLP, and they're doing excellent work. They're trying to figure out ways to do some kind of like transfer learning or training models with less data in smarter ways. I'm looking at another like the related problem, which is right now a lot of people would choose to use the English models because either of lack of availability of models in their own languages, or just because the quality of the English models is currently better. But the English models, they have been trained on text on the web, English text on the web. And statistically, it primarily comes from users in the US, which has the highest number of English speakers. And so when these models, like language models, like GPT, the GPT family, or Gemini or Llama, all these models, when they learn about the world, when they read web text, they learn about the properties of language, and they also learn about the world. But the word knowledge is very US centric, or more broadly, like Western centric. And so you get these like weird examples, like if you ask something like tipping in a restaurant, it gives you advice assuming that you're in the US, or you ask like why is someone working on December 25th, and you get a lot of reasons like they're probably an essential worker, and there's an implicit assumption that this person is necessarily in a country that celebrates Christmas, and there's no thought that maybe this person is just in a country that doesn't celebrate Christmas. That's why they're working on December 25th. And these are all like really small examples that don't sound like they could make a lot of difference. But when we take these models and we incorporate them into real world applications that can make decisions on people's lives, then we don't want them to have the implicit assumption that the norms and values of one culture are the correct ones and everything else is out of distribution.
And what do you think are the ethical considerations then that are paramount in developing and deploying NLP technologies so that they can have those otherworldly views and not just US centric views like you were saying earlier?
I think one important thing is to have multiple people involved in the development of these models, people from different cultures, different backgrounds. One thing that I'm particularly concerned about is actually something that companies have done to improve the situation, which is so the previous models like GPT-3 and previous language models, when they were consuming web text, that was obviously the web has a lot of hate speech, a lot of racism. So they were integrating that into the model, and then you would use the model, and it would generate hate speech and racist content and harmful content. And companies like OpenAI and Google, they have done a lot of work on trying to prevent that, and so which is great. But they did that by sort of like patching the models with these kind of guardrails on top of them. And I'm being very vague because these companies are pretty secretive about what they're doing. So I don't know exactly how they did that. But by doing that, even though I think it's in general a positive step, they kind of like ingrained their own values and norms into the models. And so, for example, I have questions like what is considered offensive, what is considered harmful, and this is not, there's no clear cut. And I think, at least to the best of my knowledge, this was something I was like kind of like decided by teams of software developers or AI researchers working on these models, which are primarily based in the US. And I don't even know, so I don't know whether people from different cultures were involved in that, whether people from different fields like ethicists and social scientists were also involved in that. And I'm a little bit concerned about that, because I think that these are kind of like arbitrary decisions. They change the way that the assumptions that the models make. And I'm not entirely comfortable with these decisions being made by computer scientists, and especially given the narrow background, at least in my assumption, that these are decisions made by software developers sitting in the US working for a US-based company. And so, yeah, I'm a little bit conflicted about that, because I do think that it's good that they were doing something to stop the models from generating hate speech. I'm just not entirely comfortable with the way that it's done.
In your view, what are some of the potential harms or biases present in existing NLP models, and how do you think they can be mitigated?
In that perspective, my focus has been on the culturally aware NLP, because I think that by having an implicit assumption that the values of a certain culture are better than others, you can eventually, if you deploy a model based on a language model, an application based on a language model that makes decisions over people's lives, it could actually discriminate against people from different cultures because they have different norms or because they express themselves a bit differently. And I'm a little concerned about the transparency, I think, because in multiple levels. First, because these language models or any kind of deep learning model, they are a black box. We don't really know how they make their decisions. And so if they make a biased decision, or if we have an application based on either a language model or any kind of deep learning model, and it makes a decision regarding someone's life, we don't really have a good explanation what the decision was based on. It's not causal. It's not something that you can point out a specific reason that the decision was made. It's more statistical. It's based on patterns. It can still pick up on biases, even if it's using a language model that has these guardrails. It's not airtight. There are still biases. So first of all, the transparency at the model level concerns me. Second, right now, language models are so successful. They're so impressive with the text that they generate. It looks very human-like, or even better written than the average human writing. And it very well understands the questions and instructions that we give it. And so they're useful enough to be incorporated into applications. And now they're starting to make their way into applications that actually affect a lot of people in our everyday lives. And we don't always necessarily know what's behind the algorithm that is making decisions on our lives. And that definitely concerns me, because this is not actually a new problem. It's just, I think it's becoming worse because models are better now. But this is something that has been discussed a decade ago by researchers. There's a famous book, Methods of Math Destruction, by Cathy O'Neil from, I think, around a decade ago, where she was talking about exactly that, where you have some algorithm that is supposed to make a decision on someone's life, like whether to approve someone's loan or mortgage, or whether to filter out a resume. And then you don't actually know what's happening behind the algorithm. Even the people applying that, they don't know. Even the people that develop that don't know. You can't really easily detect whether it's actually answering the question that you're asking. It, like in the example of the CV filtering, is this person going to be a good person for the job, or whether it's learning some proxy, like from biased, like past biased decisions made by people, or from the text itself. And so this problem has been around for a long time. And I think right now, when language models they're so successful and they're going to be deployed everywhere, and are already being deployed everywhere, I'm a little bit concerned about this happening in larger scale.
So how would you propose to address that issue of underrepresentation or misrepresentation of certain cultural or linguistic groups in NLP models?
The kind of simple or naive way to do that is to expose it to more data from different cultures. There is some work on that from several groups right now in the world. I can mention one or two of our works. So we had a paper last year where we showed we took it wasn't a large language model. It was more like a smaller common sense reasoning model called Comet. That was trained on, it was based on a language model and was then trained on annotations from US-based users. And you can ask it, like, you can give it a sentence like someone is doing something, and then it generates these kind of like common sense implications. And we showed that if you ask it something like, you tell it something like the person is eating a Dutch baby, then it and I would have to pause here because I realize that a lot of people don't actually know what that means. So Dutch baby is actually a dish. It's a German pancake that you bake in the oven. One thing I tell people is, even if you didn't know what that means, you would probably understand I'm talking about a certain dish that you don't know, and it's not like a literal Dutch baby, because like it's highly unethical to eat babies. And so, but the model failed to understand that. So it was generating implications like, this person is mean, they are starving, they must feel guilty afterwards. And so we had a very simple fix. We simply trained it on another data set called Candle that was collected by researchers from another group. We trained it on their data set that had this kind of like definitions of concepts from different cultures. And simply by doing that, we taught the model about different cultures. So that was a very like simple solution, where the problem was just lack of familiarity with concepts from cultures outside North America. We're doing something similar right now in vision and language. Vision and language models also, they have been trained on images from the web, which primarily come from Western countries, and again, primarily from the US. So if you ask a model, like an image generation model, to generate an image of a breakfast, you're going to get a lot of different images with eggs and I don't know, sometimes bacon or croissant or like all kinds of like Western breakfasts. We wanted to expose them to more images from different cultures, so we collected a large scale data set of images from different cultures, and then we're training a model on them. So those are very like simple fixes. They're not going to entirely solve the problem. There's two future directions. One problem is that if you're looking at the largest models, let's go back to language models just for the sake of simplicity. A model in the size of like GPT-4, it has been trained on a lot of data, so that's what makes it so good, the fact that it has been trained on a lot of data. And also, we don't really know exactly what data it was trained on. So companies are scraping pretty much, like I'm kind of like exaggerating saying all the text on the web, but it's in the magnitude of all the text in the web. And so because they know that the more data they have, the better the model is going to be. So even if we had the resources, which we don't, to take GPT-4 or like to train a GPT-4 style model or size model, which has equal representation for different cultures, we're gonna have to like downsample the data to be in the same size as the culture we have the least amount of data for, and then we're not going to have enough data anymore, and it's not going to be as high quality. So even if developers made this conscious decision to show these models more data from different cultures, the English in large language models, or like data coming from Western countries, and more specifically from North America, would still dominate. And we don't have control over that because in academia, we can't really train these kind of large models. I personally, in my group, can't compete with companies that train huge models. And the other aspect is that even if we have this familiarity with concepts, which is what we've been working on so far, it's not exactly the same as like interpreting the world through the lens of a culture. This is a little bit more complicated, a little bit more subtle. But when I'm talking to you, and if you say something, and it's let's say ambiguous, I would like interpret that through the lens of my own experience and culture and norms. And so one thing we would want to happen is if you show a language model some kind of a situation or a narrative, it would be able to interpret that from the perspectives of different cultures, or that you would be able to, I don't know, I'm not sure that's the right approach, but that you would be able to say, okay, now let's assume that the speaker is from this country and the listener is from that country. And right now it has this implicit assumption of like a Western culture.
Speaking of these like large language models like ChatGPT, what are your thoughts on the use of these AI-powered language models in educational settings, considering the concerns about misinformation, manipulation, and right now, like we said, the biases present in these models?
Yeah, I think I sometimes have to stop myself from being really skeptical and say, oh, like it's too dangerous. And dangerous not in the sense that people say that these models are too good, so they're dangerous, but more in the sense that like the hallucination problem is a very serious one. So you should be really cautious about applying it in education. At the same time, I do acknowledge there are definitely advantages, and these models can actually help improve education. And so I would be really cautious about like, developing just a language model based tutor with no human intervention, or like, attempting to replace teachers with AI, because I think that the hallucination problem is a huge obstacle for that to be useful. I think there are a lot of companies, a lot of research groups currently working on that. So once this problem is solved, I think it will be a lot more promising to use it in education. At the same time, I think it could definitely help for small things, like if a student is sitting in class and like misunderstands something, they can quickly ask ChatGPT for clarification instead of completely losing track of class, or stopping everyone and asking a basic question. it's not necessarily a substitute for going and talking to the instructor later, but it could be useful for these kind of small things. So there's a lot of concern in education about cheating, using like language models to for like students using language models to do their homework. So the concerns are about cheating and also about losing skills. I'm not super concerned about the cheating part, but I would have to say I'm personally probably privileged because I'm teaching elective courses, and I think it's in NLP. So I think the students that come to my course, they want to learn, and also I don't know, I might be naive. Maybe I don't think they have a lot of opportunities to like cheat with ChatGPT, but I might be naive. I don't think it's a necessarily good use of an instructor's time to try to like prevent using models and then like spending time and effort on detecting cheating. I think what we need to do instead is to like incorporate that into the curriculum, but in a controlled manner. So, for example, we can have some rules about how these models can be used, or ask students for disclosure about how they use them, or like allow certain uses but not others. I'm personally not a fan of using these models to replace writing. But I also know I enjoy writing, and I think that they can be used maybe for like writing assistance, like paraphrasing, editing, but again with caution. So like going over the text later and making sure that there were no like factual errors introduced and the meaning is still preserved.
Absolutely. I think the use of LLMs in education are should mostly be used as a tool instead of something to completely remove, the need for actual writing or the need for actual instructors. I wanted to ask you on the flip side what you thought about like AI text detector tools. Do you think these are necessary? Do you think these are accurate? I wanted to get your thoughts on that.
So again, I would hedge and say that I'm probably privileged because I don't teach like a first year course, so I haven't had to like deal with a lot of cheating. Um, but I personally wouldn't trust these tools, and the main reason is just because these tools are based on detecting the statistical differences between AI generated and human written text. And language models, that exactly what they do is to try to imitate the statistics of a human written text. And so the better language models get, the worse the detectors would get, inevitably. And so I don't think they're accurate. I also think that students are sometimes smarter than us and more tech savvy than us. So I heard a story, this was from a high school student that I know, who told me that they were using ChatGPT to do their homework, but their teacher was using a detector. So, and they knew that, so they also used an online paraphrasing tool. And so like after going through the paraphrasing tool, it no longer looks like something that ChatGPT wrote, and the teacher didn't detect that. And so they got away with not doing their homework properly, but it went undetected. And so in this kind of race, I think that the students will always be smarter and more tech savvy and have more time on their hands to come up with original ways to cheat. And so I don't think that's a good use of our time. And on the flip side, also, you would get the false positive cases where the tool says that the text is AI generated, but actually the student wrote it. And I'm a little bit concerned about that. I wouldn't want to be in a situation where I accuse someone of plagiarism and they didn't. And I'm speaking right now from the perspective of someone who teaches computer science at university level. I think that if in the long term, people actually the jobs would change because people use language models, then we should also equip them with the ability, the skills to use these models in a smart and critical way. And so I think it's important to incorporate into the curriculum using these models, looking at their outputs, seeing how accurate it is, judging for yourself, and teach people to use them in a better way. Because like when I talk to the general public, I got the sense that there's a lot of things that I assume that people know, like the hallucination problem, which is not necessarily known by people. So if you actually incorporate that into the curriculum, you get people that are more comfortable using these models, but are also more critical and less, completely trusting them as like we wouldn't want them to be.
Going back to model bias and diversity in LLMs, could you elaborate on what model bias means in the context of artificial intelligence and natural language processing?
So if we're talking about societal biases, so that's making some generalized claim or belief about a group of people from certain population group, or treating people from a certain population group differently from others. I don't know if there's anything else that I'm missing, but bias in machine learning, it's something that has been studied for many years now, and it stems from mostly from the data. So we train the models on data. So in the case of language models, it would be web text that explicitly contains biased or racist or any kind of like harmful content, like making a certain claim about a group of population. In the case of classification models, so LLMs would be classified under generative models because they generate text. But there's also bias in classification models. So if you take some input and you put it into a model and it needs to predict a certain decision, like in the case of a CV filtering system, these models can also be biased in the sense that they were trained on data that was biased. And that could happen, for example. So I think it's more intuitive to actually explain it in the context of a classification model, like a CV filtering system. So if you train a model to get a CV and decide whether we should like proceed with interviewing this applicant or not, the question that you actually want to answer is this candidate likely to be good at the job or not? But this is a very hard question to answer. So instead, what you would do, you would take past decisions made by a person who might have been biased, and you would train the model to predict the decision in the same manner that this person have. And so there was an example about 6 years ago, I think, from Amazon, where they had this system developed for CV filtering. And I don't know if they actually deployed it or just tested it, but they observed that it was discriminating against women. So what likely would have happened there is that it was based on the decisions of some past decisions by managers that were biased, maybe against women. Maybe they thought that women, I don't know, are less good at a particular job. There could also be lack of representation for women in the data. Maybe there were mostly CVs for men, and then when you would feed a CV from a woman in test time, the model would it would be out of distribution. So it would say, no, I don't think this is a good candidate. And also, like, if it was using any kind of representations, at the time it was word embeddings, but right now it would be the same with the language model. If you have some underlying model that is trained on web text and captures all kinds of biases, then you would also incorporate that into the model. There are a lot of different ways in which bias goes into these models, and it's because of the problem of models being like a black box that are not interpretable, not explainable. It's really hard to detect that. You have to like explicitly construct a test set where you have examples from different groups of population that are otherwise identical, and to show that maybe the models perform worse for a certain group of population. So that's for classification. It's just more intuitive to explain that. For language models, it would just be the statistical associations between different groups of population with, I don't know, some bad properties or something like that. Or like if I continue with the CV filtering example, the statistical association between men and tech jobs, for example, but the like lower statistical association for women and tech jobs.
And could you provide other examples of how bias in data sets used to train large language models can manifest in the model's output or behavior?
Yeah, so I have an example that one of the students in my NLP course discovered. So he was playing around with ChatGPT, and he wanted to see basically whether the model treats people from different population groups differently. And so he asked it, can I take my Muslim friend out for ramen? And the model started generating an answer, and then it stopped, and it like triggered the filter, and it said something about hate speech filter, even though he didn't engage in any hate speech. He was merely stating the fact that his friend was Muslim. And so what happens here is a very concerning example where the developers of this model, they put some guardrail to prevent from hate speech towards this population group. They're trying to protect this population group. But in practice, what happened is that like merely the mention of this population group prompted the guardrail or the filter, which means that, so you can't, I mean, it's not always the case, but in that case, like you can't even discuss someone who is Muslim. So that would be one example where different groups of population get like different behavior from the model. And just as a sanity check, he later asked, can I take my Jewish friend out for ramen? And he got a perfectly good answer from the model. It was like an enthusiastic yes, followed by a list of restaurants in the area.
And how does model bias in LLMs affect different demographic groups, particularly those historically marginalized or underrepresented?
I think it's, I don't know how it does right now. I think it's something that we're going to see coming in the near future, because now language models are deployed into real world applications. I think they're going to be incorporated into applications that make decisions on people's lives, and they might actually perform differently for people from different population groups, like either discriminate against them or so again, I'm giving an example from a different domain because that's something that we already know. But in the domain in computer vision, face detection used, I don't know if it's still the case, but at least used to work, the performance for faces of white people work better than dark people, or like black or dark people. And so dark-skinned people. And so we could see something like that. We could see something where if we have an application that is using a language model and is like deployed in some setup where it's making decisions regarding people, it might actually make a decision regarding an individual based on their like the population group that they belong to, or the demographics. But I don't have a particular example because I think it's something that we will start seeing as language models get deployed in more real world applications.
What steps can researchers and developers take to identify and mitigate bias present in training data for LLMs?
I'm actually a bit pessimistic about that, unfortunately. I don't know how much we can do apart from showing this problem. So I mentioned earlier, we do try to make models more culturally aware, but eventually if we're, if we have a small model that is more culturally aware and we're competing with companies that are much less careful or that prioritize scraping as much data as they can and training models as large as they can, and they're less careful and they're trying to sell a product, so they're not gonna like stop and say, okay, no, this is too biased, we can't actually deploy this model. Then I don't really know what we can do other than raise the awareness, and hopefully policymakers can do something about that, and at least force companies to be more transparent about the data they're using and where these systems are deployed.
And what role do you think interdisciplinary collaborations between social scientists and computer scientists play in ensuring that LLMs are developed with fairness and inclusivity in mind?
I think it's really important. I think we have a tendency in computer science to reinvent the wheel, as now we're like venturing into these like social aspects, and we kind of like, I mean, I don't want to like say that everyone is, but a lot of us are not super familiar with work done in social science. So I think that collaborating with people from social science that have a different perspective and different expertise and knowledge is very important, especially now.
Could you explain what common sense reasoning entails in the context of developing and training AI models and why it's considered crucial in advancing artificial intelligence?
So that is related to the generalization property of language models or models in general. So when we train models, language models on like a lot of text, a lot of online text, they learn about everything they've seen there. but then we ask them a completely new question, and we want them to reasonably answer that question based on similar examples they've seen in their training data, or just, yeah, common sense. Like we are able, so I don't have a good definition of common sense, but it's basically knowledge that is commonly shared among most adults. And so when people encounter a new situation, we can sometimes, or most of the times, interpret it correctly or do something reasonable about it, even if it's completely new to us, because we have some basic common sense facts that we can rely on in our prior experience. So we would expect models to do the same. And I can give a concrete example. I think it would be easier to explain it with a concrete example. And I would hedge and say, I haven't recently tested it. It might be that models solve it correctly now, but at least a year ago, I showed it to ChatGPT and it failed. So this was a news headline from 2019 that said, Stevie Wonder announces he'll be having kidney surgery during London concert. So it is syntactically ambiguous because the during London concert can either refer to the announcement that he made, which is the real interpretation, or to the surgery itself, which is an unreasonable interpretation because he can't have a kidney surgery, which would entail being under general anesthesia and still, perform and like sing and play at the same time. And when I asked ChatGPT, I showed it this headline and I asked, when is the surgery? About half of the times, it was first of all inconsistent, and about half of the times it said that the surgery happened during the concert. So that's an example for an error that a person would not make because it just defies common sense.
How can community engagement, you think, and stakeholder involvement contribute to the creation of more culturally aware and inclusive LLMs?
I think that there are some really good projects right now. There is a multilingual NLP project called Aya from Cohere, where they actually engage people, like volunteers, to collect data or annotate data for different languages. So I think that's a really nice effort. I'm not sure, I guess something similar could be done for more culturally aware NLP. I think we definitely, one thing that I have noticed working on this area of research in the last couple of years is that it's actually not trivial to get annotations because you have to collect them from people from many diverse cultures. And if you go to the standard crowdsourcing platforms, which we have been using so far, you mostly get people from certain countries. Like, for example, in Amazon Mechanical Turk, you mostly have annotators from the US and India, a few other countries that have a lot of workers. But it's much harder to get like a diverse set of annotators. And so we have been like finding other ways to do that, but it's really not trivial. And so I think it's crucial to not take that shortcut and try to like, find, I don't know, ask people about different cultures, or you have to actually ask people from these cultures.
And do you think that the bias that are present in these LLMs impact the trust and acceptance of AI technologies by the general public, particularly those from marginalized communities?
I don't know that it is. I think that there's a lot of hype right now, and I have talked to a lot of people in the last year and a half since ChatGPT was released. I gave a lot of like general introductions to language models to groups of people from like professional writers through like people in the medical domain to people in the legal domain. And I think there are some skeptical people everywhere, but there are a lot of people that are not skeptical enough in my opinion. And the reason is simply because, or in many cases, because they are not aware of the limitations. So more than once I have gone and give a presentation to a general audience, and I discovered people that didn't know about the hallucination problem. Even though when you go into like ChatGPT, for example, in the web interface, it does say like in small print, it says that it might sometimes write like incorrect facts or something like that. I can't remember the exact phrasing, but it's not emphasized by these companies because they want people to use their products. And so I find that right now there is maybe too much trust in these models in the general population. And I don't think we should avoid using them, but I think we should have the awareness and be very cautious about how we use them.
Do you think would it help if regulatory bodies and policymakers addressed the biases that are in LLMs? And do you think that would help in promoting fairness in the creation of these AI technologies?
I think so, but I don't really know how. I think it's a very difficult problem, partly because technology moves faster than regulation. And it's even if they, I mean, but there are still there are a lot of discussions in the legal domain right now about what to do with these models and some decisions made in different countries. But the tech companies are always one step ahead. There's always like a new model or a new capability that hasn't been discussed yet. So I think it's crucial. I'm not sure exactly what they can do.
And looking ahead, what are some promising approaches or strategies for creating LLMs that are more culturally sensitive, unbiased, and inclusive?
I don't know that this is the right direction, but one thing that I would like to see is people like NLP researchers working on additional paradigms beyond generative AI. I think that generative AI is incredibly impressive. You can do a lot with it. But right now, there's a lot of focus on kind of like patching or trying to superficially correct the problems that are inherent, like bias and hallucinations, which are they're not bugs, they're features of this approach. And so I would like to see other people, and yeah, myself included, I also don't do that because it's really hard. But I would like to see people working on additional paradigms that can complement this generative AI paradigm and maybe provide a different solution that is just free of these problems. I'm not sure what that would look like. I think it's really hard to be creative right now when everybody's working on language models. But yeah, it's a little disappointing to me that there's so much effort going into patching these models instead of, in addition, trying to come up with alternatives.
And how do you envision the trajectory of natural language processing research evolving in the next decade?
I think it's an incredibly hard question. I've never been good at predictions, and I think even especially right now when things are moving so fast, I really it's really hard to tell. I think it could go either way. It could be that soon enough someone will come up with solution to all these problems, the hallucination problem, the bias problem, the needing a lot of data problem, and this would continue to be the dominating paradigm, and then safely incorporated into applications. And there's another an alternative trajectory where these problems are not solved, or like some of these problems are not solved, and maybe somebody comes up with a different paradigm, or nobody comes up with a different paradigm, and there's, I don't know, people stopping to work on that, or the hype dies down. And it's really hard for me. I think it's probably not going to entirely die down. I think generative AI is here to stay, but it's hard for me to predict how these problems are going to be solved and how long it's going to take to solve them.
But do you envision a possibility that NLP technologies will evolve to better accommodate non-English languages and understand cultural nuances?
I think so. There are a lot of really smart people working on developing models for different languages and making them more inclusive. So I think there would definitely be improvements in that area.
And with the rise of data privacy concerns, how do you anticipate NLP techniques evolving to ensure the security and confidentiality of sensitive information?
I think it would be crucial to come up with an approach where you can train on less data, and so then you can be selective with your data. Because right now, yeah, you have data privacy issues, you have copyright issues, and I would hypothesize, I don't know that that's the case, but I would hypothesize that that's also one of the reasons that companies don't disclose their data when they train a large language model. And so if you solve that, you basically you can be very, very selective in the training data, and then you can make sure it's balanced across different demographics, different languages. It doesn't contain any hate speech or any kind of like problematic content, any copyrighted content. Right now, yeah, these models just require a lot of data. So we just, companies just train on whatever they can get their hands on.
Thank you, Dr. Bird. And just before I let you go, is there any message you'd like to share with our audience? Any advice on using these technologies? Anything you'd like to say?
I don't think I have anything else to add. I think that we live in very interesting times. I think that it's very exciting and like a bit overwhelming to do research in NLP right now. But it's all, yeah, it's overwhelming, but it's also really exciting. When I started in NLP, I really didn't think we're going to get to the point where we have models that generate this kind of like very human-like text. And so I am excited about what the future brings and where else it can go.
Absolutely. We're very excited as well. And thank you so much for gracing our podcast, for the time and the valuable insights that you've shared with us. And of course, thank you to everyone who has joined us on this enlightening episode of the AI Purity Podcast. We hope you've enjoyed uncovering the mysteries of AI generated text and the cutting edge solutions offered by AI Purity. Please stay tuned for more in depth discussions and inclusive insights into the world of artificial intelligence, text analysis, and beyond. Don't forget to visit our website, that's www.ai-purity.com, and share this podcast to spread the word about the remarkable possibilities that AI Purity offers. Until next time, keep exploring, keep innovating, and keep unmasking the AI. Goodbye, everyone. Goodbye, Dr. Brett. Thank you so much for being here. We
Thank
appreciate
you
you
for
so
having
much.
me.
Thank
Thank you.
you. Talk soon.
Bye.
Goodbye.